Now we'll go ahead and look at Statkey. And I clicked on sampling distribution for the mean. So you go down to sampling distribution, select mean. Now I'm going to go ahead and just I'm going to hit the drop down. I'm going to try Olympic marathon in minutes. And I'm going to just generate one piece of data here to begin with. You'll notice over here we have our um, actual data from our original population. And I'm going to go ahead and generate one sample from that, and we get this. I'll generate a second sample. We'll get this one here, and that's shown to you over here on the right. This one here is shown to you on the right over there. And I'll slowly keep taking more and more samples from our population. And you'll notice they all vary a little bit. Now, instead of just generating one at a time, I could generate more. I could generate 10 at a time. I could even generate 100 at a time. Or I could just start generating 1,000 at a time. Now, up here, our population mean was 41.1. Oh, down here, our mean from our sampling distribution is also 41.1. 0.04, where up here it was 0.05. Really pretty close. So once you get enough samples, your statistic that we're concerned about, for the most part, matches the mean of your population. Now, notice your standard deviation of our sampling distribution is up here. That's your standard error. So now let's go back here and try this for our proportions. So let's see, I guess we'll do the college grads. We'll just do one sample here. Our proportion of college graduates is 0.275. We'll do another sample, and we'll continue to do this, looking at our proportions. And now we have 10, so I'll generate 10 at a time because I don't want to just keep pushing one. And we could even go up by hundreds, redoing our proportion each and every time, or redoing our sample from our population. And I like to generate around 5,000. It doesn't have to be, but that's just a personal preference. Now, you'll notice the mean of our sampling distribution is 0.275, which matches exactly with our population parameter up here of our proportion. We also have our standard error.